so excited to be here with you today and explain how we have built a user behavior analysis engine on Amazon. So let's start. It's lunchtime. Thank you for coming. Let's start with a little bit of activity. Raise your hands if you are building digital products. Okay, so people who didn't raise their hand, they're building bridges or maybe highways or something. So keep your hands up if you know your daily active users or monthly active user count. Okay, good. Keep your hands up if you know how your users are behaving and why they're behaving a certain way. For example, why some users are dropping off a funnel, or some users are converting, how the user behavior is different across web versus mobile. Good, good, very good. And keep your hands up if you can answer this question or questions similar to this in less than 30 seconds. Good. I'm glad to see that we have people who can do that. That's great. And I'm sure a lot of you who have problems, I'm sure that you're thinking about answering this question. It is very important to know that this is an important problem. At the same time, it's a very complex one. The average consumer is spending more than 200 minutes every day interacting with digital products. And that does not include playing games or social media. These are the work that they do, like their healthcare or finance or the way that they do work. And all of this is tens and thousands of events that we are collecting from the users. You can accumulate vast number of data, however, it's not going to be useful until you can use this data to understand how the user is behaving. That's part of the reason that a lot of companies and products are not successful, because they really don't understand how the user are behaving. And understanding user behavior is the key to building a product that people want to use. Actually, I know two founders who started a speech recognition app. They built the app. There was an app for Android that would convert voice to text. They built the app, and after that, they were trying to understand how the user are interacting and find out if they're building the right products or not. They realized that it's very hard to answer these questions, and they decided to build their own analytics tools. These two founders were actually Amplitude CEO and CTO, Spencer Skate and Curtis Lowe. After they built the analytics tool to understand, they realized the value of building analytics solution that can democratize data and make it easier for teams to understand their data and find out how they can build better products is more valuable than actually building their speech recognition app. I'm glad they made the choice. I joined the company later on, and as an engineering leader, I have seen in the past a lot of time that we are trying to build a lot of things without knowing the value that it would bring. So if you can understand your user product, if you can understand how the user are behaving and how they're interacting with the product, you can build better products. For example, companies like Netflix, they do this thing. They they collect data. You collect event-based data and analyze and uncover data insight, and based on that, you take action, and you keep repeating until you gain insight. And you do that all the time because you want to make sure that your users are experiencing great behaviors and are using your product properly, and you're building the right product for them. So as we try to see how we can build such a solution, we first need to understand what question we need to answer. For example, Atlassian, who is a customer of us, probably you are using, if you're using Jira, they wanted to answer this question. They wanted to know how many Jira users engage with Kanban view. And people who are using Kanban view, how is their behavior different than people who are not using Kanban view? Is there any correlation with users that are using Kanban view with their long-term retention? And they also want to answer this question quickly, because they ask one question, they get an answer, then they ask the next question, that they get another answer until they get something actionable. And so basically, anybody who wants to build a solution that does user behavior analytics has to have this characteristic. It has to be exploratory because the users usually don't know the right question to ask the first time. They ask this question and they gain insight. It has to be fast because if you ask a question and it takes a couple of days or weeks to get the response, you lose the context and you cannot gain that insight. So you have to be able to interact with the system and get that knowledge. It has to be flexible because you want to ask multiple questions and other questions. It has to be cross-platform because your users might be connecting with your product over web or mobile and so on and so forth. And it has to be user-centric. It's all about the users. This is a very, very high-level architecture. Basically, we are collecting the data from different sources. We're enriching the data, transforming them, cleaning it up, and making it possible in a way that we can query them fast and efficiently. For collecting the data, you have to look at all of the data sources the data comes through. We have an SDK that our users can install in the application, so we can collect the data directly from the mobile devices or web, or some of our customers actually collect the data themselves. It goes to the server, and we collect the data from the server-to-server connection. And also, some customers have third-party tool that they're sending the data through them. You have to collect all of these data. At the same time, we have, we allow a flexible ingestion through Amazon S3. So if any of our customers already have data in Amazon S3, they can easily send that data to us. After collecting all of these data, you have to transform them. First of all, we have to make sure that we are doing things at a very high scale because we're collecting a lot of data about user behaviors. Another thing that is very, very important is that we have to maintain data accuracy. Because if you don't trust the data, no analytic, nothing else after that matters. And we have to make sure that we have ways of uniquely identifying user. I'm going to explain that in a couple of minutes. As we are doing and getting all of these data, we have to do these things to make sure the data is clean. For example, an example of that is the deduplication that we need to do. If a customer is sending their data to their mobile device and their mobile device doesn't have a good connection to the internet, it might send the data but doesn't get the access the data has been received. So it might try to resend the data. So you might receive the same data multiple times. So you have to make sure as you're ingesting the data, we're deduping and reducing and making sure that we're getting the accurate data, as well as doing a lot of other things. This is an example of a data that comes in and the enrichment that we do. As we see, we're adding Amplitude ID as well as some other user property that we knew about the user to that event that we're collecting and having at Amplitude. So let me explain to you why we need to have an Amplitude ID. Last weekend, I went to San Diego for Thanksgiving break with a bunch of my friends. And as I was planning my vacation, we decided that we want to rent an Airbnb home. So I was on my laptop. I was not logged in. I went to Airbnb's website and looked for houses in San Diego. And then I got distracted. And later on, I went on my mobile phone and went to Airbnb and app. I was already logged in. I looked at options, and I sent an email to my friend. They said, this is a good option. Then I went back later on to my laptop, and this time I had to log in because I logged in, and then I made the reservation. So if you look at the behavior that I did with Airbnb app, sometimes I was interacting as an anonymous user, sometimes I was interacting as a logged-in user. If we want to know the behavior of the user end-to-end, we have to know all of these events, and we have to identify this particular user. At the same time, if we don't do that, we might counting one user multiple times. And that's why people have a hard time knowing their daily active or monthly active user, because they're inflating the user count as the user are interacting different ways through the platform. This is another example of, sometimes users are logged in and sometimes they're not. So basically, in order to keep track of accurate count, we keep track of the user ID, which is the ID that the user has in that app, as well as the device ID, which is the identifier of a physical device that they're connecting with that. And we try to create an Amplitude ID, which is the unique ID that we assign to every app. Here is an example of how we do it. Let's say that the user opened the app on a device A and the user is not logged in. At that point, we have no information. We don't know who that user is. So we assign a new ID to it. Let's say Amplitude ID 1. Later on, the user logs in, and it's now user Bob. But because it's coming from the same device, we say this must have been the same user that we saw before. So we assign the same ID 1 to it. And then if user Bob goes to a different device, let's say device C, we are going to still use user ID 1. However, later on, we see another interaction, another event from a user that is on a device ID B that is not logged in, again, anonymous user. At that point, we don't know who that user is, and we might decide a new ID to that, user ID 2. And then later on, if from the same device, basically the user logs in and we see Bob again, we realize that the previous behavior was probably from Bob on that device. And we realize that Amplitude ID 1 and 2 are actually referring to the same user. We merge these two IDs to make sure that we have a great global view of all the user activity. And we do it retroactively, and we don't have any limitation of how many of these users you can merge, because it's important to have the global end-to-end view of the user. Another thing that I mentioned that we do is that adding a user property. It's important that we add this information, and user property are associated with the user. For example, if I'm here, connecting to an app, it might say that Shadi is connecting from Las Vegas. So that information would be as part of the user attribute that is adding to that event. And if my future event doesn't have a location, that information can be added so we have that overall view. When later on I go back to San Francisco, it's going to show, if it sends a location, again, that is San Francisco, then that would be added to user property, so the future event would have the right, basically, location. Our user, actually Amplitude user, can go to our UI and see the user attributes. And we decided to use DynamoDB for keeping tracking of our users' properties and being able to add that. DynamoDB is a great tool because, first of all, it's a key value store. It's a simple API. It's flexible. Each user have different attributes. You can do that. But at the same time, it was very important for us because we have billions of users, and there's a very high rate of events coming, and we need to add them. So having that tool that can easily and flexibly scale, we don't have to worry about it. Having that service was very valuable for us, and we actually use DynamoDB for that. To recap, basically, our ingestion needs to collect a lot of data. We need to make sure we maintain the data accuracy and uniquely identify that. Today, we are basically processing about 1 trillion events per month and within our architecture. Let's go back to the high-level architecture that we have. We already talked about the collection and enrichment. Let's talk about the query side, the fun part. Here is an example of an analysis that we do at Amplitude. We call it a pathfinder. What happens is that the user might define an important event, and they want to see how their user get to that event. That important event might be buying a song on a site like iTunes. So if that's an important event for you, you can see how users are actually converting and ending up buying a song. It could be before that they might be viewing the sign. It might be that they have gone and joined the community. So it's very important to have that insight into that user. So if you look at it, how this is happening, basically underneath, we are looking at multiple events from a single user to see the transition that is going through. So basically, we are joining events of a single user, but we are also doing across all of our events, all of our users, to be able to have this holistic view of how users are converging and moving toward the path. This is what we call the complex distributed join. We need to have a solution that can support these complex distributed joins to allow us to provide this analytics. Actually, we started our solution basically doing basic pre-aggregation. At the beginning, we had basically doing simple segmentation or funnel analysis, and we pre-aggregating the data as they were coming so we can show this result fast. If you remember, I mentioned that for any analytics solution, it's very important that it has a fast response time so the user are keep engaging with the tool. So at the beginning, we are doing pre-aggregation and we are doing our simple charts. But we realized that we are hitting a limit, and we cannot do complex joins like the one that I showed in Pathfinder. And we realized we need to change our architecture and have a more complex architecture to handle these complex queries. And that's why we built our own solution, which we call it Nova. Nova is Amplitude proprietary columnar storage, and we can actually process more than 1 billion events in less than 1 second. And it was built, purpose-built for us for user behavior analytics and doing deep analytics on that. So let's explain how we're doing Nova. So we are actually following a Lambda architecture. If you remember, I mentioned that every solution that we have, it has to be real time. You need to know how your users are behaving right now. It's not good to just say that what the user did last month. However, as we are thinking about how we can do that implementation, it's very important to know that one of the good attributes about user behavior or event is that you usually don't change the events. The event happened and they stay that way. However, there is a slight difference about GDPR that you might have to go and delete event. But other than that, your events are immutable. The data that you have are immutable. You don't have to change it. So for that, we should be able to find an optimized way so that for batch data, for the historic data, we can do them fast. At the same time, you create a speed layer for the real-time data. So as the data is coming, it's going both to the speed level as well as the batch level. Speed level is running on memory, and basically it's more expensive, but it has short amount of data. And every so often, like every day, we collect those data and we batch them and put them in the batch layer. And our query engine in the front, when it receives a request, it asks both the speed level as well as the batch level to get the result and merge them and show the holistic view to our customer. Let's now focus, how do we do things in the batch level, batch layer to do things efficiently? We actually are using a columnar storage. I'm sure all of you know what's the difference between row storing and columnar storing, but I'm going to explain a couple of minutes about it. Traditionally, databases have been using row storage model because they were mainly used for transactions. It's easy to add or modify a record. You get a record, you basically write it down as a row in your database. However, the problem is that you might read unnecessary data. So if somebody writes a SQL query, select a name from the table, you're basically going to end up reading the entire table, throw away the columns that you need, and just show the value of the field name. On the other hand, columnar storage is storing data in each different columns in a different file. And the good thing is that when you need to read something, you only read the relevant data. So if you have the same query, select name from the table, you don't have to read all of the other fields. You only need to go and read that particular data. And for us, as I mentioned, for each event, you have a lot of data that you're storing. But most of the time, the customer don't want to get all of that data. And they're interested in a few of them. So having columnar storage really gives a benefit. And also, columnar storage is very good. On the other hand, columnar storage is not very good for updating data because you need to go and update to a lot of things. But in our case, because our data is immutable, we don't have to worry about that. So columnar storage is really suitable for read-only, read-intensive, which is an example of analytics that we have. So we decided to use columnar storage. But we are not the only one who are. Columnar storage has been around for 30 years. There's a lot of solution. And actually, Amazon Redshift is a good example of a solution that is a good service that if you use that, we don't need to go and reinvent the wheel, and we can just use that service to get the value. BigQuery is another example on Google, HP Vertica, they're open source solution as well. However, we decided that we want to use our own because we needed flexibility. And it was very important for us to handle everything, and as I said, we are creating more and more analysis to answer harder and harder questions for our customer. So it was very important for us. The engine that we are using is flexible enough so we can add and analyze more things on top of that. At the same time, also, everything is very user-centric in Amplitude. So by using that condition, we know that we can basically create a more optimized structure and architecture, because we know that a lot of joins that we are doing are across user, and we don't have to use a general purpose. Building a special purpose engine can help us optimize and do things faster. The way we decided to do our model that we are following is a kind of a similar to a MapReduce model. For people who don't know MapReduce, I'm sure a lot of you know already, but in a MapReduce model, you have a huge amount of data and you want to run an operation. Here is an example of doing a word count. What you do is that you basically split that data into a number of sections. So in this example, we're splitting in 3 sections, and you have 3 workers work simultaneously on that data together. And they calculate the result. Each of them are going to do this counting during the map process. The next process is that to merge this data, basically there is a shuffling. To move these around, you do sorting and shuffling to move things around. And then at the end, you basically things that are relative are in each different location. Then you do reducing and you find your total count. So we can do similar things at Amplitude. So assume that we have 3 sets of users, and we want to calculate the funnel conversion for these 3 sets of users. In each of them, you know that how many are registered, what happened with view, and how many are added, and how many purchased. You can do that. However, if these 3 sets of users are disjoint, we actually don't need to do a shuffling and reduce phase, because all you need to do is add them up, because you don't see the same user happening in these 2 different places. So and that can, if you can create the data that way, you can really improve the performance of processing. One of the usually cost element of any MapReduce job is shuffling. So if you can reduce the amount of work that you need to do on shuffling and moving the data, that can really improve performance. Actually, in reality, our data is not 100% disjoint, because as you remember, I mentioned that we do some of this merging. Some users, user 1 and user 2 in the Bob example, actually happen to be the same user. So we might have to do some small shuffling, but we can optimize in a way that majority of the calculation is happening on where you have all the data and you move small amount of data, because we know that this case it doesn't happen a lot. So using that, we can basically improve our performance significantly. And that would allow us to do this complex distributed join. You'll see that you're looking at different attributes that, the events that the user have gone through, and our query engine can gather that data, and then we can merge them and answer any hard queries that you might have. Some examples of queries are what you can see here. For example, one of our video streaming solution customer want to know which shows are being binge watched by customer. To be able to do that, you have to look at customers and be able to basically look at all of the events from that customer, merge them and join them and find which shows, and then do it across to find the shows that are happening. And that's what we call it the complex distributed joins that we do at Nova. With our analytics, now we are giving our customer tools to interactively explore their data and answer these questions. And because this is a system that we built in-house, we have the flexibility to add more and more and innovate and add more analysis on top of that. We started with just doing basic funnel and chart, then we added Pathfinder, and we have also added a solution that basically clustering of the user. What we've done here is that we look at all of the user, and we are using a K-mean algorithm. We are clustering users, so we know what kind of users are retaining, so that we can use and look at the behavior of these users. And we could only do that if we have a flexible engine underneath to allow us to do these complex queries. Today, Amplitude is serving 30,000 different products, and we are basically processing events from 7.5 trillion users, and we are serving more than 20 of the Fortune 100 companies. One of the most important things that we think we do is that we've served our customer by helping them not worry about building analytics. They can actually focus on building their app, and they can use us to give us analytics insight for that. Actually, one of our customers, head of analytics at Live360, says that we went with Amplitude because we didn't want to spend any more resources and time on building internal infrastructure. we are not an analytics company. And we want the customer to actually focus on their core product and not worry about analytics. By having Nova and having this ability, we have been able to create this interactive way of creating insight. And now that we have this space, our customers actually can use that to collaborate with each other. We have people in our customers, basically, one person might go and ask questions, gain some insight, then they can share that chart and that analysis with somebody else who can build on top of that and create more and more insight. And we think that's what it's very important to have an analytics company. It's very important to break the silos within organizations so they can work together and answer questions and build better products for their customers. Okay, thank you so much for your time. Any questions? Yes.
There's $7.5 trillion.
Yes.
For what period of time is that?
These are because you can query all of your data.
Yeah.
So you can query that goes back a year worth of data. So all of our data is 7.5 trillion data that you can go back. Yeah. Yeah. Yes.
How long do you keep the data?
We can keep the question is how long do we keep the data? We can keep the data indefinitely. So because we believe that it's not just important to know how the customer is doing last month. You might want to look at. You have an option in your calculation to say how long do you want to limit your search, but you're able to go as far in advance as you want to go. Yes.
You talked about Nova, but you also said that you keep user properties in Dynamo.
Yes.
And I'm assuming there is a join between the two databases if you want to create a funnel based on user properties. So I was wondering how that works.
Yeah. So what happened, the question was that we are using DynamoDB for our user property, and then we use Nova to serve our queries. The way we do it that at the time that we're ingesting the events, we are adding those attributes and those properties to the events. You saw in my example. We are adding them, exactly. So now you have the information in there, you have all of them, and then you can do your complex join on top of that.
But you also said that I can update
Yes.
properties.
Yeah.
And if you smeared them in Nova, how do you update it considering it's read-only?
Yeah, that's a good question. Is that how do we update property? It's very important to know that the way we do it is that at the time that we are getting the event, we have these properties for the user. As in the example of me moving from Las Vegas to San Francisco, when we change the location to San Francisco, you don't want to change my previous events to be changed to San Francisco. My previous event happened in Las Vegas. So now from that point on, we are applying that information. So as we get the event, whatever property, user property that we have, we add to the event, and that's for that point of time for that event. However, the one that we do retroactively is mainly for user ID resolution. So if you had identified that it was user 1, and then we also user 2, but actually you realize that user 1 and 2 are the same, we merge them, and we keep that information in a mapping table so that during our query time, we can merge all of that result and provide that information. Thank you. Any other question? Okay. Thank you so much. Thank you.